The advice is to change everything into sines and cosines. That means your tangent should have been what? Sine of x over cosine x. Do you have to write this down? Remember, this was my attempt that didn't work. A beautiful thing I saw. Somebody took this black denominator. What'd they write instead? They wrote sine. And that's a great attempt. That's so great because what they thought of on their notes from the other day is that sine squared plus cosine squared. Remember, the 2 goes after the trig function when you're squaring it, equals 1. So why did they think that 1 minus cosine was equal to sine? If you minus the sine to the other side, you get negative. If you subtract this, you would get black cosine squared. And that is equal to 1 minus red sine squared. I'm going to try to be super intentional with the colors because it'll help us out. Now, why is this denominator, that black denominator, not equal to... Oh, shoot. I should have subtracted what to the other side? I should have subtracted cosine, but the same thing works. The reason why it's not equal to sine is because there's no cosine squared in the bottom. So that's a tricky thing, okay? We got to make sure we're paying attention to that, okay? Now, could they have square rooted both sides? Yes, they could have. They would have just had to plug in the square root of 1 minus, you know what I'm saying? Like, it just makes it more complicated. So that's not a route we would want to go down, okay? So, great attempt. But again, you're starting to feel the weight of like, shoot, didn't work. Now, you can remember this is equal to the red box, okay? I'm not going to write down the red box over and over again. So, what's a good step now? I've got a fraction within a fraction. Is that fun? No, so let's get rid of that. Let's just make it 1 top, 1 bottom. What do you have to do to make that happen? Keep, change, flip that mug. Come on. So keep your green. Keep. Oh, still keeping. Change your black division to a black multiplication and flip 1 over 1 minus cosine x. Oh, baby. It looks like we're getting somewhere. Come on. Looks like we're getting somewhere. So, then, if I make that into 1 fraction, what happens? What's on top? Sine of x. What's on the denominator? Is it 1 minus cosine x squared? Cosine x minus cosine x squared. Because what do you have to do with the green cosine and the purple? What's that called? You have to distribute. Okay? So there's that temptation again to, when we know this thing, when we know this for a fact, sometimes we just try to like invent steps to get there. Okay? Because we're like, oh, dude, I know it's going to be that. And it's not. Okay? So that's a great attempt. Let's distribute that green cosine. Should I write cosine times 1 or is that confusing? All right, cosine and then minus. I'm going to do a green cosine times a purple cosine just to show that we distributed. Okay, so again, this is not the attempt that works. So if you don't want to write this down, that's fine. So sine of x all divided by cosine x minus cosine x squared. I've got a cosine x squared. Can I plug something in for it? What can I plug in for cosine squared? Cosine squared is 1 minus sine squared. Let's try that. Are you guys bored yet? Dude, guys, this is hard. It's the hardest thing we've done all year. Hey. Guys, there is one person that wants to be a math teacher in here, and this is for them. All right, so then I'm still working on this problem. Am I getting anywhere close? Now, I actually just read this business book called The Dip. All right, that's on the front side. For real. Kind of like a weird. I like wish I was a business guy, but I'm like a math teacher. But so I like read and listen to business stuff, which is like what am I? I'm just a math teacher. Anyway, so you got to know when you're in the dip. This is not a part of my plan, so sorry. But when you're in the dip, according to this book, this little book, okay, this is where we're trying to get to, right? But you got to know. You got to know if you're in the dip or or if you're on a cliff. Homegirl's on a cliff right now. Okay. If we keep going in this direction, we're kind of just going to be turning our wheels. It's kind of a dead end. Dead ends and cliffs are kind of both bad, what this guy says. His name's Seth Godin. He writes a blog post every single day. If you want to be a business person, I would check him out because he is a smart guy, and you will be probably a better worker if you ascribe to what he does. Okay, so now I've got 3 things in my denominator. Again, is this a dip or is this a cliff? This is a cliff. Let's get off the cliff. Not like go backwards, not jump off, you know. Okay. So this is a cliff. Let's not stay there. Now, do you guys want to know the trick? Actually, you probably don't actually care that much, but let's assume you did want to know the trick. I'm going to tell you. Okay. I'm going to read copy down the question. Tangent x. Oh yeah, why is my face? I don't know. Let's get my face out of there. If you know how to turn my face off, let me know. Aw. You actually watched them? That makes me happy. I assume nobody watched them. But there's this thing that it's like, should I still do my job even if students don't do their job? And the answer is, yeah, I should. All right, so put a big box around the right side. Here's the trick, okay? You're going to be really annoyed. A good move when you have something minus something in the denominator is to multiply by the conjugate. You want to introduce a difference of perfect squares. Is a difference of perfect squares when it's factored? Does it have a plus and a minus, both a minus or both plus? Like if you had x squared minus 9, that would become what? X minus 3, x plus 3. So again, this is just a strategy. This is not the way to do this every time. This is a strategy to have in your back pocket, okay? So you can multiply by the conjugate. That is 1 plus or 1 minus cosine? Plus cosine. What's legal in algebra? You can move stuff. You can multiply by 1. This is just a fancy way to say 1. Is it 1 right now? What makes the red thing a 1? It's got to be the same thing on the top and bottom. So it's got to be 1 plus cosine x on top as well. Now, it might seem like you're going onto a cliff, but I promise you're in a dip, all right? You're on the dip right now. For real, that's a good book. Seth Godin, he's solid. It's also really short, too. He's like a short writer. So it's you can actually get through the book and not just like have it sit on your shelf for like 6 months. All right, so now what should I do? Distribute the bottom or distribute the top? Top? What's the bottom called? Foiling. We're going to distribute the top, foil the bottom. So we've got a black tangent plus a black tangent times a red cosine. What did I just do to the top? I distributed the tangent. Now, what am I going to do to the bottom? Foil. So what's 1 times 1? 1. Then outside, 1 times negative cosine is a negative cosine x. What? Yes, Anna. Well, it's tangent times 1, so there's my tangent. And then it's tangent times cosine, so it's tangent cosine. Great question. Keep asking good questions. This stuff is hard. I am acknowledging this stuff is hard. Okay. Now, inside, red cosine times black 1 is a red cosine. And then we've got, what's your last? Positive or negative? Negative cosine x times a red cosine. Is anything in the bottom a like term? By the way, this is the correct way to do it. We should have this on our paper. Okay? I promise this will get us to the answer. What's a like term in the denominator? The negative cosine x and the positive red cosine. The black cosine times the red cosine is not a like term because it's cosine squared. So in the denominator, all you're left with, let's copy down the numerator, tangent x plus tangent x cosine x. Do you have to write the x every time? You don't have to, but I will. I got murdered by a PFW professor when she evaluated me during Max's class one time. She called me out for the whole class. It was low-key embarrassing. I was like, dude, you should have just told me after class. Why'd you have to embarrass me? That's all right. Oh, what's in the bottom? 1 minus cosine squared x. What's that the same thing as? Sine. That is the same thing as sine. How do I know that? Because I remembered. The Pythagorean theorem is our best friend, okay? So anytime you have 1 minus cosine squared or 1 plus cosine squared, that's probably telling you that you need to use the Pythagorean theorem. So my numerator, is it still the same? Yes. Can I change it all to sines and cosines now, or do you guys want me to wait? Let's do it now. So I have sine over cosine. Then draw your big fraction bar. What's on the bottom of that big fraction? This tangent is the sine over cosine. What's on the bottom of the big fraction? Just sine squared. What do you do with the other one? That's a good question. So then we've got plus. What should this black tangent become? And what is that multiplied by? Cosine x. Do we see how now things are starting to get canceled? Again, I did not expect you to do this, okay? I literally was like, no one is going to get this. And if you got it, good for you, okay? Now, should we cancel out the cosines? Yes, we should. So we're left with a green sine over cosine divided by a big black sine squared x. Then I'm going to separate my fractions. Big fat plus. What's left of the second fraction? Just sine divided by what? Sine squared x. Again, now things are starting to get canceled. This is what we like. By the way, I will say this. Our next test, I'm not sure. What do I have to do to this thing right here? I would keep change flipping. Sine of x over cosine x times 1 over sine squared x. What does the other fraction become? 1 over sine. You've got a sine on top, 2 sines on bottom, so it becomes 1 over sine. They canceled out. You had 2 on the bottom. You had a green on top, so they canceled. Now, can anything else get canceled? The sines in the other fraction. Oh my gosh. All right, so you've got 1 divided by cosine x times a black sine x. Where'd the sine x go that was on top? It canceled with the 2. Then I'm going to go ahead and change that other thing to a cosecant. what does the other fraction become? If it's a cosine on bottom and a sine on bottom, that's what times what instead? Secant is the cosine times cosecant is the sine. I do want the sines and cosines, but remember what I'm trying to get it equal to. I'm trying to get it equal to cosecant times 1 plus secant. So are we almost done? Last step, what is it? Can I add these? They're not like terms, so you have to factor out. They're not like terms because they're not the exact same thing being multiplied together. Great question. So cosecant times, what's left of this first thing right here? Secant. What's left of this cosecant? 1. So are we done? Yay. Are we happy? No. We're happy to be done. We're mad that this problem is the worst. This is a verified. Yes. How do you get verified? Can somebody tell me?